Okay, what we're going to look at today are absolute value inequalities. So think about this. Think about if we have the absolute value of x, and let's suppose we're saying this is less than or equal to, let's say, 3. Okay, so this is an absolute value inequality. Now let's see what that looks like. This is saying what numbers can you take the absolute value of and either get 3 or something less than 3. So let's just look at a little number line here. And I'm going to put 0 here. And here's 1, 2, 3. Here's 3. And over here is negative 3. So think about this. If it's less than or equal to, that means that 3 is included. And negative 3, because the absolute value of negative 3 is equal to the absolute value of 3, which is equal to 3. So we know we have to include those. Now let's think about the inside here. What about 1? Is 1 a part of that solution? Well, the absolute value of 1, yeah, that's less than 3 because it's just 1. What about negative 1? Well, the absolute value of negative 1, that's equal to 1, which is less than 3. So that's included. And in fact, all the numbers in between negative 3 and 3 are part of the solution. So we could say the solution goes like this. Negative 3 to 3. And notice the equality. I'm including, in my interval notation, I'm including those endpoints. So that's a solution there. Now, let me look at a little bit different problem. Let's suppose that we've got the absolute value of x is greater than or equal to 3. Okay, so we still could look at a number line. And we've got, 0 here. Here's 1, 2, 3. And we're going to include 3 and negative 3 just like before. So here's negative 3 and here's 3. So we still include these points. However, we're saying greater than or equal to 3. Now, the absolute value of 1, see, if we look at that, the absolute value of 1 is not greater than or equal to 3. In fact, it's less than 3. But what about the numbers on the outside? What about 4? The absolute value of 4, well, that's equal to 4, and that is greater than 3. So what's on the outside, numbers on the outside here, that's part of our solution. Well, what about negative 4? In other words, what about over here, negative 4? Well, the absolute value of negative 4 is equal to 4. That's definitely greater than 3. So we can see that on this side over here, that's part of our solution. So what we would say is anything from negative infinity to that negative 3, that's part of our solution. If you give me any number between negative infinity and negative 3, that's going to satisfy that inequality. Or if you give me anything bigger than 3, from 3 to infinity, that's part of my solution. So that would be the solution to this inequality, this absolute value inequality. So we see here we've got two things. We've got less than or equal to, greater than or equal to, or strictly less than, strictly greater than. We'll look at different examples. But let's just see here. Let's suppose that we've got 2x plus 1 is less than or equal to 5. Okay? And then let's look at a similar one, 2x plus 1 greater than or equal to 5. And let's look at the two approaches that we would use here. So this one, it's pointing at the absolute value. So here's the way we do this. We say, okay, 2x plus 1, it's got to be between 5 and negative 5. And we get this inequality. See? So it's pointing at the inequality. at the absolute value. So that means our solution, we have, like this one here, x is less than or equal to 3, or greater than or equal to negative 3. See? So here's the type of situation that we have. So this is the inequality, and we have to figure out, well, how do we solve that? Well, I'm going to subtract 1 from all three regions. See? See? I get 2x less than or equal to 4, greater than or equal to negative 6. Okay? Then I divide by 2. This is different from a regular inequality or a two-sided equation, because on those, what we do to the left, we do to the right. Now, what we do to the middle, we do to the left and to the right. So notice we've got x less than or equal to 2, greater than or equal to negative 3. So there's our solution, negative 3 to 2. So every time you have an inequality, an absolute value inequality, where it's pointing at the inequality, where the inequality is pointing at the absolute value, you put it in the middle like this. Now let's look at the other one. Let's suppose that, so we've got this one, 2x plus 1 greater than or equal to 5. Well, we set this one up this way. Okay? So what we're going to do is, just like this other one, where we have greater than, notice we're going to do this. We're going to say, okay, now looking back at this one, look what we did. We said x, it can be less than or equal to 3, negative 3, or x can be greater than or equal to positive 3. See? In other words, it can be over here or over here. Less than or equal to negative 3 or greater than or equal to 3. So we're going to do that this way. We're going to say 2x plus 1 less than or equal to negative 5, or 2x plus 1 greater than or equal to positive 5. Notice the difference in how I set up these two problems. Now I have two inequalities to solve. So I'll subtract 1. Negative 6. Divide by 2. Or divide by 2. So now notice what I've got. I've got negative infinity to negative 3. Or, that's going to be the union, 2 to infinity. So you see the two different types of problems. Greater than or equal to, less than or equal to. Now, these are just the basic ones that we're starting with. You could have a variety of types of inequalities, but these are the two types that we're looking at right now. Okay, now let's look at a couple more here. Let's suppose that I have the absolute value of 2 minus 3x less than 5. And let's think about how we would solve that one. Notice the inequality is pointing at the absolute value. So that means we have 2 minus 3x less than 5 greater than negative 5. See, it goes between this number and its opposite. Then I subtract 2. And we get this, negative 7 less than negative 3x less than 3. Now I'm going to divide by negative. Now here's the thing. Whenever you divide by negative, it switches the inequality direction. See? Every time you divide by negative when you're working with inequalities, you change the direction of the inequality. So now this says 7/3 is greater than x, greater than negative 1. So I could write that, switch the direction here. Like that. And now we have this. We have the inequality, the equality wasn't included, so it is negative 1, 7/3. Like that. Okay? So it's very important that we swap the inequalities. Now notice, when I change the direction of the inequality, I got this, and then I wanted the smaller number on the left, so I kept the inequality pointing at the smaller numbers, but I just changed the order. Now let's look at another one. Let's suppose I've got the absolute value of 5 minus 2x greater than 7. Okay, so now it's pointing away from the absolute value, so now I've got 5 minus 2x less than negative 7, or 5 minus 2x greater than 7. Okay, now we just solve both of these. So I subtract 5 from both sides. Now notice I haven't changed my direction of the inequality. I added negative 5. I didn't divide or multiply by it. I just subtracted it. Okay. Now I divide by negative 2. And notice I get x greater than 6. See, I swapped the direction of the inequality. Okay, or subtract 5, and I get negative 2x greater than 2. Divide by negative 2, and I get x less than 1. See? So I get this. I get that on the one hand, over here, this is going to be x. We're going to go from negative infinity to 1, not including the 1, so I put a parentheses. Over here, we've got 6 to infinity. Now, I want to put these with the smaller interval. In other words, I'm coming from left to right, so I'm going to write this way. Negative infinity to 1, sorry. Unioned with 6 to infinity. All I did was just change the order, so I'm coming from negative infinity to infinity from left to right. But the important thing is, here, you have to remember, when you divide or multiply by negative, you change the direction of the inequality. To help you see why that's the case, think about this. 2 is definitely less than 3. What if I multiply both sides by negative 1? Well, I've got negative 2 and negative 3. And if I don't change the direction of the inequality, I would be saying negative 2 is less than negative 3, which it's not. So I need to be sure and change that direction. Okay, so let's summarize. If you have the absolute value of some expression less than or equal to some value on the other side, you immediately write that as negative p on the one side and p on the other. So in other words, this is the inequality that you end up getting. On the other hand, if you have the absolute value of some algebraic expression greater than or equal to p, you write that this way. X less than or equal to negative p, or x, the big X, the algebraic expression, greater than or equal to p, like this. So 5x minus 2 less than or equal to 3, this would be negative 3. Okay. 5x minus 2 greater than or equal to 3. That would be 5x, 5x minus 2 less than or equal to negative 3, or 5x minus 2 greater than or equal to 3. And there you have it. And then you just solve these. So on the one hand, you have this compound inequality, and on the other hand, you have two inequalities.